Hi, my name's Alan Sal, and I help students master AP Physics 1. I actually want to share today a story about when I really understood a process, a really embarrassing story with my college freshman year professor's office hours. So basically, I was coming in with some problems, and this is we were learning mechanics. It was basically the equivalent of AP Physics 1. It was calculus based, it was an honors physics, so it's a bit harder than what you guys are doing in AP Physics 1. We were working on momentum, or we're just working on a problem here, and it was this block that was sliding and another thing landed on top of it. And I was trying to say like, well, when it lands on top, it's just going to keep going with the same speed, right? It's just going to keep moving with the same velocity. And it's okay if you don't, when you're watching this, you don't know your physics stuff yet. But basically, that's not a principle we learn in physics. And my professor was trying to say like, okay, imagine you had a little ant crawling along, right? And I dropped a bowling ball on it as it was sliding, right? Would it still be going the same speed? And then I was like, yes, because I didn't want to be wrong. But I look back and I was like, wait, that was really stupid. I don't know. My professor must think I'm an idiot. Like of course it's not going to move the same. I have a little ant moving. I drop a bowling ball on it. Yeah, it's not going to move at the same speed anymore. He was trying to get me to see, and he did get me to see, ultimately that the velocity would not be conserved, right? What would be conserved instead is what he was trying to get me to think. And that's where it's like, oh, momentum is conserved in that situation, right? And then I was like, now I get what I'm supposed to do. So there's a process, there's a logic, and that was a really eye-opening moment for me. Even despite my embarrassment, despite the fact that I was wrong, I really didn't understand the principle very well, or I didn't understand to apply it in that situation. That was a really eye-opening moment for me, and I really realized, I need to think about these principles more analytically and not just like what I think is going to happen. I have to think about why is that principle applying in this situation and what is the effect of that. So it really refocused my efforts. So it was good that I was willing to show up to office hours, ask a question, and be wrong, because that's the best way that I was going to learn and be corrected, right? Otherwise, I would just gone with this mindset that like, oh, well, I got it wrong. Go look at the right way. But it was more impactful. I still remember that moment almost 20 years later. That moment was a defining moment for me in physics class, right? I've learned so many things over the years that I have forgotten at this point. But that moment was really clear for me on why I needed to be there, why I needed to be asking those questions, and why I needed to develop in my own mind a process to look at and break down problems. Right? So I just wanted to share that story with you. Hopefully you can relate to that experience. Put a comment below. And if you're afraid to be wrong, and if you're afraid to ask questions, then that is going to limit your ability to grow, limit your ability to really learn and master the material. So let me know in the comment if you can relate to that.